Hey folks, how's it going? It's Mr. Murray coming to you with a do now for Course 1 Honors for Friday, June 5th, 2020. So, here's the situation. You finally made it to the Encore Casino. You've mastered probability and think you can use it to your advantage, so you start with the Blackjack table. So the values of each card for Blackjack are shown in the diagram below, and I'll go ahead and scroll down to that in just a second. Here are some basic rules of Blackjack. And so these are the rules we're going to assume. I know that there are others other than this. I know, but I'm just going to go with these rules just for the sake of this problem. Okay, so in Blackjack, we start by giving you two cards. You're dealt two of them. So if you're dealt an ace and a jack as those two cards, you immediately win and you say Blackjack. Okay, and then that's it. Otherwise, you start with your two cards, you add up their values, and then you say hit, and the dealer will give you more cards as long as you say hit, and then once you're done, you say stand, and then you're done. Okay? After you finish, the dealer then deals. They're required to continue to hit until the sum of their values is 17 or higher. Finally, if at any time the sum of all of your cards' values added up is more than 21, or the dealer, whoever gets that sum more than 21 busts, which means you lose. If it's you or if it's the dealer, you actually win. So here are our cards right here. We can see our card deck, and you can see the numbers underneath. So ace is 1 or 11. That's actually your choice. And then we have the numbered cards. Their values the same as whatever number's on them, right? 2, 3, 4, 5, 6, etc. And then jack, queen, and king are each worth 10. So what we need to do is first figure out what's the probability that you're dealt a blackjack. The second question is, what is the probability that you're dealt two of the same card? Now, when I say two of the same card, I mean two cards that are the same but different suits. So, for example, the 5 of clubs and the 5 of hearts, the 8 of spades and the 8 of diamonds, the jack of hearts and the jack of spades, something like that. Okay. Third, what's the probability you're dealt two face cards? And finally, what's the probability that you're dealt two cards with values less than 10? Other assumptions. Assume that every card has an equal probability of being drawn. You can also assume that you go back to 52 cards for each problem. So you start with 52, you start with 52, etc., etc. Okay. You also are going to assume that this is done without replacement. So what that means is that you deal the first card and then you deal the second card. You never put the card back into the deck. And lastly, don't worry about the dealer's cards. Assume that the only cards that are being dealt to you. Okay, so considering the rules of Blackjack, these assumptions, and the cards in front of us, the sample space here, please pause the video, calculate these 4 probabilities, then when you're ready, unpause, and you can see what I got. All right, folks, time to check out the answers. So this problem basically comes down to what we call the multiplication rule. You might have seen that I actually wrote that at the beginning. So the multiplication rule says that if you want to find the probability that two events happen, so both one event and the second event happen, you take the probability that the first event happens and you multiply it by the probability that the second event happens, given that the first event has already happened. Now, the big takeaway is that when there's independent events, the probability that B is going to happen given A already happened is the same as the probability of B. So when they're independent events, it looks like this. Probability of A and B is equal to the probability of A times the probability of B. because the probability of B given A, if they're independent, is just the probability of B, because since B doesn't depend on A, the fact that A has already happened should not influence the fact that B is going to happen. Okay? So, let's see what we got here. So, first of all, we're assuming the cards are drawn without replacement. So that means we actually have dependent events, because once a card is removed from the deck, that impacts the probability that another card is going to be drawn. If I want the ace of spades and a card is already drawn that is not the ace of spades, now the chance I'm going to get it has increased because there's only 51 more cards to choose from. So the probability of getting a blackjack. So what that means is that first we either get an ace and then a jack, or then a jack and then an ace. So what that means is that there are essentially 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cards, which if we saw them, we would know that we still have a shot to get a blackjack. And there are 52 cards in the deck total. So that's the probability that we're going to get the first card that we want, either an ace or a jack. Once we get an ace or a jack that's been dealt to us, there are now only 51 cards remaining in the deck. Because remember, we're doing the probability that B happens, that we get whatever other card, given that we already got its partner there. Okay? So what we have is, if we got a jack, basically, there would be only 4 cards we want. And if we got an ace, there would also only be 4 cards we want. Okay, so it's going to be 8 times 4. And you can count up the possibilities if you want to do it as a counting experiment. So this with these 4, this with these 4, this with these 4, this with these 4. That's 16. And then 6 with these, 6 with these, 4, 4. So 32 total. So 32. And then we got to do 52 over 51. So it's 2652. And so 32 over 2652 is approximately 1.2%. So you have a 1.2% chance of getting blackjack. Okay? Now, that's basically a 1 in 100 chance of an event happening, even though the name of the game is named after it. I don't know. You tell me if that makes sense. Jury's out on that. All right, dealt 2 of the same card. So in the beginning, you can get whatever card you want. It literally doesn't matter. But once you've been dealt that card, there are only 51 cards left in the deck, and there's only 3 other ones of that card. So think about it. Let's say I want to pick a card, right? I want to know if I've got a shot at getting doubles. In the beginning, when you get your first card, you're going to say, okay, why? Well, because the first card, it doesn't matter what you get. You're always in contention to get doubles. But once you see, once you get a 9, for example, you're going to know, well, I'm going to need one of those other 3 9s, right? The other 3 out of 51 cards. Okay, so 52 over 52, that simplifies to 1. So I'm going to cross that out to indicate it doesn't impact the value of the final result. And 3 over 51 is equal to 1 over 17. Okay, and 1 over 17 is equal to approximately 5.9%. In other words, you're almost 5 times more likely to get doubles than you are to get blackjack. Now you know why they don't call the game doubles. All right, now let's do the probability you're dealt 2 face cards. So in the beginning, right, remember there's 52 cards in the deck. Of those 52 cards, there are 3, 6, 9, 12 face cards that you could be given. So there's 12 cards where if you get it, you know you still have a shot at 2 face cards. Now you deal 1, so there's only 51 cards left in the deck. And of those 51, only 11 of the remaining are face cards. Okay, so now we simplify, and we get 132 over 2652. And that is approximately 5%. It's like 4.97, so approximately 5%. Okay, lastly, dealt 2 cards with values less than 10. Now, we could probably assume that ace could count. It depends whether you want ace to count. So if I want ace to count because its value could be 1, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9 cards in this suit whose values are less than 10 times 4 suits. So in the beginning, there are 36 cards that I could draw, where if I draw them, I know I'm still good. And now that I've drawn those 36, there are only 51 cards left, and only 35 of the good ones left, right? Because one has already been drawn. So now I simplify. So I get 2652 on the bottom, and I get 1260 up top. And so what I get is approximately 47.5%. If I do ask you for a fraction and it's a simpler fraction, you should try to do some kind of simplifying. It would be good. I kind of cut corners here and didn't simplify just so I could show you the answer. Okay, so hopefully you're able to get these right. If so, congratulations. Keep up the wonderful work. This is, again, a problem based on the multiplication rule. So it's really important you take a look at those activities and then you try the MyHRW homework. But best of luck, folks. Don't forget to love math. And remember, you can do it.